Hey guys, Chris here. This video is going to help you solve the unit problem. Okay, so if you can think back to, I believe it was 3 Fridays ago, we started working out the unit problem in class. And this is the equation that most of you started with. Negative 16 f squared plus the initial velocity times f plus h is equal to 0. Now, where does this equation come from? This is our general free fall time equation, just instead of using t's, I'm using f's. Why is that? Well, because the specific t we're talking about for this time is free fall time, right? It's the time it takes from the diver to get from the Ferris wheel to the cart. So if we imagine our little cart right here, it's the time for him to go wherever he's released down into the cart, if you can see that. Okay. So we know what v sub I is in terms of w, and we know what h is in terms of w. The initial velocity is 7.85 cosine 9w. I'm just going to write that. Cosine of 9w. This is something we generated in class in outcome 7, 7.85 cosine 9w. We also know the height in terms of h, and that's something that we generated back in outcome 1. So last quarter is 50 sine of 9w plus 57. It was plus 65 originally, but we had to take into account the fact that the diver was falling into the cart, which was 8 feet above the ground, and not to the ground. So what we can do is we can substitute vi and h in for vi and h in this top equation. So that becomes negative 16 f squared plus vi, which is 7.85 cosine of 9w f plus h, which I'll have to write down here, 50 sine of 9w plus 57. All right, so we have this monstrous looking equation, and I apologize, it's going to get even worse, because we actually have to solve for f. We have to have an equation for f in order to solve this problem successfully. So we have to have, like, in other words, we have to have f is equal to something, something. Well, how are we going to solve this equation for f? How are we going to get f by itself in this equation? Well, we have a helpful tool, and that's the quadratic formula. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And what is my a, what is my b, what is my c? Well, those are the coefficients, in this case the algebraic expressions, in front of the f squared term, the f term, and then the last coefficient. So what is my a? Well, the number in front of the f squared is negative 16. What is my b? Well, the number in front of the f is 7.85 cosine 9w. It's actually not a number, it's an algebraic expression, and that's okay. And c would be everything that's tacked on to the end, the 50 sine 9w plus 57. Okay? So here's where it gets really, really messy, because we have to put all of these expressions into the quadratic formula. So what's that going to look like? Well, f is going to be equal to negative b, which in this case is negative 7.85 cosine 9w, and it's plus or minus, but let's think for a second. Because we're going to be dividing everything by 2a, which in this case will be negative 32, that's 2 times negative 16, we'll want the top part, the numerator, to be negative as well, because a negative divided by a negative is always a positive. So what we're probably going to want to stick with is the minus, just the minus solution. We can only have one solution for fall time, okay? So we're just going to go with the minus one. So minus the square root of b squared, which in this case is 7.85 cosine 9w, all of that squared, minus 4 times a, which is negative 16, times c, which is all of this, 50 sine 9w plus 57. All over 2a, which I can just simplify to negative 32. Whew, that was monstrous, huh? Can you guys all see that? Hopefully you can. I'll repeat it again just to make sure that we have it, because this is a crucial piece right here. Negative 7.85 cosine 9w minus the square root of the quantity 7.85 cosine 9w squared minus 4 times negative 16 times 50 sine 9w plus 57. And that's times this whole quantity over here. Okay? So that's our fall time equation. Now, what do we do with that? Well, we know that in order for the diver to land successfully, I'm going to erase some things so we just have a little bit more room. In order for the diver to land successfully in the cart, the position of the cart, x sub c, has to be equal to the position of the diver. So in other words, the x position of the diver has to be equal to the x position of the cart, otherwise he's not landing in there, right? So what is the x position of the cart? We'll start with the cart. Well, from a while back, last quarter, we generated this equation, negative 240 plus 15 times w plus f. Well, do we know what w is? We don't. That's what we're trying to solve for. Do we know what f is? We do. We have this long, complicated equation that we just generated for f in terms of w's. So we can use that. Do we know the x position of the diver? Well, you guys generated something last quarter. I believe it was 50 cosine of 9w. That should be on your equation sheet. But there's another extra layer to this, because this 50 cosine 9w isn't considering the fact that he's actually going to be traveling some distance to the left as he leaves the Ferris wheel. So we have to tack on an extra piece of this. This is just the initial position, but what we're going to do is we're going to add the diver's speed, which his speed coming off the Ferris wheel is 7.85. And actually, I take that back. Instead of adding, we're going to subtract it. Why are we subtracting it? Well, because he's most likely going to be traveling. Let's see. I take that back. We would be adding it. Yeah. So 7.85 sine of 9w. The reason why I had to think about that for a second is because the diver, when w is in this region right here, will automatically be negative. So we're not going to be subtracting, we're going to be adding, because by adding, we're taking into consideration that when he's over here, his initial velocity leaving the Ferris wheel is going to be negative. So we're not quite done yet, because we have to multiply all of this. This is a time. We have to multiply by the fall time in order to get his new position, leaving the Ferris wheel. So here's what we have. We have the x position of the cart, we have the x position of the diver, and we have the fall time. What has to be true about these two? Well, these two have to be equal. So what you can do is you can create this massive equation now with this, with the f plugged in, equal to this with this f plugged in and try to solve for w. How are you going to do that? Well, my best recommendation is use a graph. Try graphing x sub c at x sub d. And what will you come up with in the graph? Well, you'll have two different graphs, and at some point those graphs will intersect. What you're looking for is you're looking for that intersection point, because that'll be the point when these two are equal, and you'll be able to determine that with real time. I hope that's a help. Let me know if you have questions. Remember, this assignment is due Friday, along with everything else from Outcome 7. Thank you, guys.